The insulin control system is much more important than just controlling blood sugar and being associated with the development of diabetes. Let me explain myself. I think most, even lay people, understand that insulin is connected, to blood sugar and controls blood sugar, and is associated problems with those issues is associated with the development of diabetes or having diabetes. Let me first describe that, and then describe the further importance of the system as it pertains to the development of any disease, and how it's connected to the development of cancer and Alzheimer's and cardiovascular disease, diabetes, autoimmune disease, osteoporosis, etc. All right, what does insulin do? It's a hormone. It's secreted by what are called beta cells of the pancreas. These beta cells of the pancreas react to blood sugar elevations, which happens from eating sugar or starch or things that taste sweet or drinking alcohol, for example. And the insulin should be released appropriately, the appropriate amount of insulin for the appropriate amount of that type of food that triggered the blood sugar spike. And what that insulin does is it goes to the cells of the body and allows those cells to take in sugar for energy. And if this system happens perfectly, so be it. Now, abnormalities in the system can obviously lead to developing diabetes or having prediabetes and similar blood sugar related issues, but it ends up being way more important than that. See, the cell prefers sugar, carbohydrate, for energy. It can use fat as well. But the cell is much more preferential in using sugar, and the thought is because it's just much more efficient in utilizing sugar for energy. And the cell, like anything, uses energy to do everything. Any closed system can do nothing without energy. The planet Earth would be a barren, lifeless place without the energy of the sun. Right now I'm moving around. What's that related to? The energy I'm speaking to. That's energy in my body in general. I'm getting down to the cell level. My cells need energy to function, to build things, to fix things, to clean things, to make things, etc. And the primary mechanism of doing that is via sugar, which is controlled by insulin. Just understanding that, it should become apparent that if that system's not working quite right, we call that insulin resistance, which I'll explain, the cell's not going to be processing, utilizing energy. And that, simplistically, would be a simple explanation for myself on why abnormalities in that insulin system can lead to cell dysfunction, which leads to the development of all those problems, Alzheimer's, cancer, etc. Obviously, if the cell doesn't have the energy to clean things, to make things, to build things, to do things, it's going to develop problems over time, which, connected to other things, genetics, aging, and other problems, could lead to those disorders and diseases later. All right, now how to evaluate this and errors that are done. Now, one huge error from a doctor perspective is not understanding that system is associated with abnormalities outside of just developing diabetes. Imagine because that's what the typical doctor thinks. If you have a problem with that, you can develop diabetes, and that's about it. Not true. One huge one error. One other problem is, when doctors look at these reference labs and they see these quote-unquote normal ranges, that's just a reference of a group of people. And most of these people aren't the most healthy people. They're people that go to labs. Who are these people? Older people, people that see doctors, people that have problems. So these reference ranges that we consider to be quote-unquote normal aren't really optimal or healthful at all. So the typical doctor, when they see a fasting glucose of 99 or below, 99 milligrams per deciliter or below, oh, you're fine, everything's great. Where the reality is, the fasting blood glucose, blood sugar that's optimal for the typical healthy person is below the 75 to 85 range. So even 85 or 86, which most doctors would think is outstanding, shows potentially some abnormality with the system. That's one other problem. So problem number one in assessing these things is they don't understand how it's connected to things outside of diabetes. Problem number two is assuming that there's only a problem maybe when the blood sugar is 100 milligrams per deciliter or above, whereas problems are potentially there when it's 85 or above. And then I think the biggest problem is they don't challenge the system. So they're looking at a system when it's unchallenged. It's, for example, if I'm trying to determine how strong someone's bicep muscle is, I can't just look at the bicep at rest and measure it at rest and necessarily determine how strong that bicep is. I test it, I challenge it, I line up a series of dumbbells, 5, 10, 15, 20, 25, 30, etc. If a person can lift 5 pounds and not 10 pounds, they've got a very weak bicep if they're trying to do a bicep curl, for example. If they can go all the way up to 65 pounds, man, you are very strong. So you need to test the system to see its strength. So you need to test the insulin system. You need to challenge it with a sugar starch meal. You can do this with the glucose tolerance test, or you can do it with other tests that, for example, I'll do mine with a bagel to give the person starch, also gluten, and jelly, or for example, a rice cake with jelly to have a non-gluten starch, the jelly obviously being the sugar. Or you can do the glucose tolerance test. You check the sugar 2 hours later, and it should be back to where it came from. Another abnormality, as long as, remember, it should have came in below 85. Most doctors are comfortable as long as it's not above 100. And 2 hours later, it should have been pretty much back to that 85. Most doctors are comfortable if the levels, as long as it's below 140. Okay, I'll tell you the biggest advantage I've had in my training and my experience is actually getting a fasting insulin and then checking the insulin level 2 hours later. Again, a typical optimal fasting insulin will be the 6, 7, 8, 9 range, something like that. Most importantly, 2 hours later, it should be back to that. If not, that individual has insulin resistance. I view it as a path towards a problem. So I tell the person, you're on a path towards a problem. I don't know how long the path is. I don't know how fast you're walking. I don't know where it leads. But it can lead to things like cancer, diabetes, Alzheimer's disease, osteoporosis, cardiovascular disease, et cetera, et cetera, et cetera. So that's why it's crucially important for the clinician, the patient, if they're interested in anti-aging and getting to the root of problems, is to understand these intricacies of the insulin system. Thank you.